Okay, so this is by request because some folks were feeling like the stuff that I had previously posted was a little bit too overwhelming, and that some of the sample IAs that I've given you were a little bit too perfect. And so I wanted to kind of break it down, what you can do as far as when you're, and things to pay attention to when you're doing the write-up. The first thing I want to say is there is no set format. You can have whatever sections, headings, etc. you want. It doesn't have to be by like introduction, methods, whatever. You can call it whatever you want. You can format it however you want. If you want to put things in tables, you can. If you want to write paragraphs, you can. You need references for anything that you're drawing from, like a protocol that you use to base your experiment off of. That can either be footnotes, or you can do it like parentheses and then have a bibliography at the end. However you want to do citations is also fine. Just keep it consistent throughout the document. Okay. Usually you want to start with some kind of introduction to your research question. What is your research question? And how did you come up with it? Or what aspects of chemistry are involved in answering your research question? So you have to talk about the chemistry behind it, not just what you did. So in most cases, the places where you've found materials that are helping you with your protocol also have information about the chemistry that you can look up. You can also do other searches if you can't find stuff in your textbook. So talk about the chemistry behind it. If you're doing something with reaction rates and concentration, talk about collision theory and how when you have more particles colliding, you have a higher probability of collision, and so that makes the reaction go faster. Stuff like that. You can include diagrams. You don't have to make the diagrams from scratch. If you find one that you really like from a website, you can take that and just cite it. Just make sure that anything that you did not make yourself from scratch gets a citation. Please include whatever chemical reaction is happening, the actual chemical equation. A lot of people last year didn't do that. And you know, it's chemistry. You need to talk about either the reaction or the process. What is the process that you're studying? If it's a phase change or something like that, vaporization, you know, what is, even like distillation, like talk about what is the actual process that's happening in your steam distillation of the limonene. What is the reaction that's happening to the vitamin C when it encounters the iodine solution that you're titrating it with? That kind of stuff, okay? The basic stuff about the research question should go probably in an introduction. Usually, you're going to have some kind of methods or procedure section next. That should include why did you choose those specific temperatures or times or concentrations? You know, what made you design your experiment the way you did? You should list your variables. Obviously, your independent variable and your dependent variable, but maybe other things that you may or may not have control over. Things that you're trying to control to keep the same, things that you may not be able to control. That can be bullet points, it can be lists, it can be tables. I'll show you some examples. And then obviously your procedure, your sort of recipe for what you did. It doesn't have to include details like, and then I poured the substance from the flask into the graduated cylinder. You know, like it doesn't have to be that level of detail, but it should be, somebody should be able to repeat your experiment. If they were to walk in this classroom over the summer and have access to all the same stuff, they should be able to repeat your experiment and exactly the way you did it. If you did any pilot experiments to start with, even if they didn't work out well, if you like tried something and it didn't work, or if you did a test run, you know, at a temperature that you ended up not using or something like that, talk about that here. That is personal engagement. That will get you points, all right? So if there's anything that you're like, well, I wasn't sure, so I did a test, or I did these tests, or whatever, like talk about that. Any kind of pilot work that you did. Depending on your experiment, you may also want to put pictures in here. You can either, if you have an experiment that for which pictures would be good, like a titration, it can either go in the methods or the results, kind of up to you. And depending on how you're formatting it, those could be all together. I don't know. So after you've talked about what you did and how you did it, you also want to talk about what you got. You should have raw data, like the actual measurements you took, not averaged or processed or anything. If you are collecting data, like with a laptop, and you're taking a sample every second of whatever it is that you're measuring, you don't have to put every single piece of data. You should have at least a sample of your data, maybe one condition for some period of time, so that the moderator can see, oh, this is what the interface looked like, this is what, these were the numbers that were coming out of the colorimeter or the spectrophotometer or whatever. With uncertainties of your measurements, if you did any calculations, calculating rate of reaction or something like that, show a sample of that calculation. You don't have to show every single one, but you have to show an example of what you did so that they can see that you set it up correctly. And then any process data that you have, whether it's averages or if you're taking 1 over the natural log of the reaction rate to do the calculate the activation energy, something like that, that would go after you show them the calculations. You would then say, and here's what I found. You need at least one graph. Got to have a graph. Kind of silly if you don't have some sort of graph. Now, if everything just totally fails and you don't have any data at all, obviously you don't have a graph. But whatever you have, put it in a graph. I'll talk about that in a minute. Qualitative data. What did it look like? What happened? Was it a vigorous reaction with lots of bubbles? Did it turn a strange color? Did some of the samples turn a strange color, but some of them didn't? Did it look squishy? Did it, there's all kinds of things that you could talk about here that give some insight into your results. If you're doing titrations, maybe you say something like that. This is where you talk about where you decided the endpoint was. When did you decide that the color had actually changed to blue? And maybe include a picture of this is what my endpoint looks like versus this is the way it started, so that they get the idea that you tried to be consistent with that. So basically, whatever you got, and then show it with, you can have tables of raw data, you can have tables of process data. You should have at least one graph showing your IV-DV relationship. And then after your results, you can, again, format this in just one big section or multiple sections, however you want to do it, that should include your conclusion. What do you conclude from your experiment? And please, this is another thing a lot of people last year didn't do, tie it back to your research question. Even if you didn't answer your research question, bring it back and say, so my data suggests that this might be happening. That's not what I expected, but here might be some reasons why. Or I expected this, and this is what happened. So make sure you tie your research question back in at the end when you've gone through all your data. And then evaluate your experiment. Be honest. Don't be, you don't have to be honest about every time you spilled something, but if you did one of your titrations, just you went way over the color, it was just a very, very dark blue and clearly went past your usual stopping point, say that. That's a source of error. That could have messed up your average calculations for that condition. Yes? Yes. if there was an obvious source of error, you're doing a combustion experiment and you know that you're losing heat to the environment. You have to say, I'm losing heat to the environment. You have to talk about, I tried to minimize the loss of heat by using a heat shield or using this, double-walled calorimeter or whatever it is you're doing to try to eliminate that, but you know you're losing heat. And so what effect is that going to have? Well, that means you're going to be underestimating the energy that's released by the alcohol that you're burning. So what is going to be the impact of those possible sources of error? And how could you mitigate it in the future? What could you do differently? And then another thing that most people last year didn't do is what's an extension that you could do? If you were handing this project over to somebody and said, please pick up where I left off, what do you think that they should do next? Or what would be some possible interesting other related questions that, given what you saw, like maybe you didn't see an effect and now you're wondering, I wonder what is the makeup of a Lego since it's not dissolving all the way in acetone. Maybe there's different kinds of whatever it is, ABS, something styrene, and maybe if I had access to more analytical tools, it might be interesting to look at that. Or maybe I should try it with 3D printing ribbon instead of a Lego because the Lego's too big and too thick. That's the kind of thing that I'm talking about. Say what you could do next. That's a point right there. And if you don't have it, you lose that point. Okay. Does this all make sense? Does anyone have questions about this so far? Okay. Again, it's very flexible. It's very much up to you how you want to put it together. So in Canvas, and I will put those 2 slides in here as well in the same module. I added some more sample IAs. These are actual sample IAs from Einstein students since I've been here. Okay, my 2 best papers from last year, Braden and Talia, doing some very different things, showing some very different types of data. Bladine did her experiment at home because this was right when COVID hit. So she did the vitamin C titration. I put this in here because it talks about the vitamin C titration and the Canterbury protocol. And you can see she scored well. I mean, granted, that year they were probably scoring more easily than they are this year, than they're going to this year. But she ended up with a 5. And so not a bad write-up. A lot of the score comes more from the write-up in some ways than it does from the experiment itself. So if you hit all the checklist things, even if your experiment was kind of, another vitamin C. She did brands of orange juice. You're not supposed to do brands of orange juice. She got a 5, okay? So pay attention to your write-up and what's in the rubric. And then I also put in an unnamed, poorly written write-up of an IA that was also not particularly well done. The person did it very last minute, didn't put enough time into it, and didn't put enough time into researching the chemistry behind it. So that scored very poorly. But just so you can see kind of not the absolute floor. That's not the worst one I've ever gotten, but something that you want to avoid. Okay. So, and I also put, I think I had this up earlier, but I don't remember, and you may not have noticed it. I put up the rubric, the official scoring guide that the moderators use. Please look at that, because if you don't look at it, you're going to miss things, and you're going to lose points that you didn't need to lose. Okay. You can also use the checklist. Is it this one? Yeah. So the checklist is set up kind of according to the parts of the rubric. And so all of the boxes here are things that moderators are looking for when they are deciding whether you're getting a 1, 2, 3, 4, or 5, or 6 in exploration, or whatever it is. Obviously, you're not going to be able to check every single one of these boxes, right? But use this as a reminder to include things. But don't use this as a substitute for also looking over the rubric. so you can see the language that it's in. So there's a few things of like things to avoid, things to do. Avoid in your exploration or in your introduction. My great-great-grandmother always had a bottle of hydrogen peroxide in her medicine cabinet, and I just wanted to know, how it decomposes. Whether that I still have that bottle from my great-great-grandmother, and I was wondering if there's any hydrogen peroxide in it. That's not the kind of story you want to tell. You can talk about what interested you, but it doesn't have to be. I've always wanted to know how much vitamin C was in the orange juice. Anyway, I'll let you look through this. What I want to do is just show a couple of these briefly and then talk about data spreadsheets. So Braden's an overachiever, and even though his experiment actually didn't work out very well, he did his write-up in LaTeX, and he actually made all of the figures himself. You don't have to do that. You can find a figure online and copy and paste it and cite it. But anyway, so he did hydrolysis of sucrose, and he shows, here's sucrose. Look, it's a chemical structure. Here's the chemistry of sucrose. There's a reaction called hydrolysis in which we break this bond. Here's an image of this reaction happening, and where the bond gets broken. Here's stuff about the catalyst, and we're going to look at the rate of reaction with different concentrations of the catalyst. And you don't have to put in a hypothesis. You can, but it's not like a required thing. The research question, statement of the research question is required. A hypothesis is not required. Notice the footnotes. He's doing them in line in the bottom of the page. Methods. His is actually a lot of writing because he wanted to use the polarimeter, but it didn't come in time, so we had to jerry-rig this crazy semi-quantitative result or experiment. It was a little bit crazy. So he's writing a lot of stuff about justifying what he was doing. Here's the reaction that's actually happening in the test tube when for the thing that he's measuring. So you're not necessarily going to have all of this text when you're talking about your methods. Here is a table of possible confounding variables, things that could have affected the results of the experiment. Temperature differences across reaction. What's the control? Well, we had to do it at the boiling point, so controlled it as best we can by making it at the boiling point of the solution. This sort of thing. You can look through it. He lists equipment and chemicals. You could put that in a table. You could make it a list like this. Safety. You have to talk about safety. All right. I don't care if you are mixing baking soda and vinegar. You have to talk about safety. You have to at least acknowledge it. If you're doing a database, you have to say, because I did this completely online, there were no safety or environmental issues with this experiment. You have to say something about it or you're going to lose points. He writes out his procedure in sentences. You don't have to do that. You can do it in bullet points or numbered list. Step 1, step 2, step 3, that's fine. Results. Here's a table of results, actual measurements from the titration. He has a separate thing for analysis because he had to do this crazy mathematical analysis of his results, which took up the entire whiteboard last year. And so he has to talk about, how did he do those calculations and put those in the paper. Now, this is another reason why he used LaTeX, because it's easy to do equations in LaTeX. I don't expect anybody to learn how to use LaTeX in order to do your IA. I certainly don't know how. Here's a graph. It's a scatter plot with dotted lines connecting the different values and a best fit line fitted to the data. He's got uncertainty calculations for all the measurements that he took. And then the discussion. How did it go? Here's the limitations of my findings. This is how it relates to what I expected to happen based on the literature. Again, limitations of the experiment. He didn't actually do an extension in this, so he lost a point for that. And then he's got his references at the bottom, collected bibliography, whatever you want to call it. 12 pages max, 6 pages minimum. 6 pages is not hard to fill up if you have any kind of graphs or tables. Okay. Let's look at Talia's. Oh, wait, not there. Because hers is a little different. Yeah? Question? Oh, okay. So Talia did a oscillating reaction, and she's very clearly starts with the research question, and then introduction. Why is she interested in kinetics? Saw a video of this reaction, was interested in this idea of oscillation, wanted to figure out how it worked. Background, she had to put a lot more chemistry into this because it's actually an extremely complicated reaction with 11 steps. She did not have to know all the details of all the steps. I mean, she pulled this out of a paper that described the steps. She didn't have to know that off the top of her head, okay? But she did have to talk about it because it is a complicated reaction. Here's the different steps of the reaction that eventually makes it stop cycling. Note these equations are simplified for the sake of understanding in space. Okay, you might have to do that. That's fine, as long as you acknowledge it. She also has a hypothesis. Again, you don't need to. She clearly states independent, dependent variable, and then again, a table of controlled variables, why it matters, and how she's going to control it or attempt to control it. Procedure and safety. So she's got her materials, she's got her procedure. She does it as an outline, sort of more stepwise, as opposed to writing in paragraphs. Either way is fine. Justification for why she used the colorimeters instead of some other way of collecting data. This was an initial test that she did to determine what frequency, what wavelength she was going to use. And she actually said frequency, but she meant wavelength. So this was just a test of different wavelengths, and she picked one of these. So this was like a pilot experiment. It goes in the methods. And so because of the data that I collected, I decided to use this wavelength because it had this characteristic. Safety, ethical, environmental issues. Please put them in. Data tables. So she was collecting a sample every second in the colorimeter from 4 different colorimeters at a time on a laptop. She didn't have to write those down, which is nice, but she's not going to include 300 lines of data from one trial, okay? So she does the first 10 seconds, shows the first 10 seconds, shows that she's got transmittance and absorbance of one of the colorimeters, transmittance and absorbance of the other colorimeter, and says each trial has a table that looks like this and goes up to 300 seconds. She does not need to put all of her raw data in here. She does not want to put all of her raw data in here. The moderator would, or she wouldn't have room for anything else. So, sample. She didn't even have to be this long, but this is nice. A nice little picture of what the actual data looked like. Qualitative data, what did it look like? Sudden change between colors. Here is it was a little bit lighter blue than she expected. There were bubbles in the cuvettes, which comes into play later. So this is a qualitative piece of data, an observation that she made that is then going to come back around when she gets to evaluating. Calculations for making up the solutions, calculations for the absorbance, And then, again, she's got multiple graphs here because she's got a lot going on. This is representative data from the different concentrations. All right, this is just one run at each different concentration. She's plotting them together so you can see, the size of the oscillation and how long it lasted, et cetera. So that's a nice kind of overview of what the experiment looked like. She looked at whether or not the oscillations got longer or shorter over the course of the reaction, and if there was any difference in that between her different concentrations. She didn't really see much of a difference, but she analyzed that and reported it. This is the main graph. This is it. This is concentration versus the time that the oscillation cycle. So she's got 4 data points. It's okay. That's fine. I would have added a best fit line here, but it's fine the way that she plotted it. She's got a conclusion section. She explains kind of where some of those graphs came in. Sources of error. Things like bubbles that were caused by the hydrogen peroxide could have affected the transmittance through the cuvette and the reading from the colorimeter. So here's a possible thing that she could try to do before, if she was going to do this again. She's not actually going to do this again, and we didn't actually try to do this, but at least it's acknowledging that that was a potential issue. So that's the kind of thing that you want. You don't have to have a long list, but you need to have at least a few things that could have affected your results. And then if I were to further investigate this reaction, here's what I would like to do, is maybe an intersection between concentrations of different things, the different reagents, and then she's got her bibliography. So some similarities between these two, some differences. You don't have to use either of these as a template or, again, these were the 2 best scoring ones from last year. But hopefully gives you a little bit of something to model off of. Feel free to use it as a template and make the same sets of tables or whatever if you want. So Braden, I think I gave him a 20 or 21 that got moderated down to an 18, which was annoying. Talia's didn't get sampled, so I don't know what they would have given her. I think she ended up with a 17 or a 16 out of 24. Yeah. Yeah. So that's some insight into the write-up. You'll see, if you go look at the one that's bad, you'll see that it's really bad, and I expect all of you to do better than that. I don't care if your experiment worked or not, but I'm not going to show it to you here. Yes? A 3 out of 24. Yeah. Yep. Yeah, it was pretty bad. It was somebody who didn't put a lot of effort into it, and particularly didn't put any effort into understanding the chemistry behind it. So pretty much all of the write-up was inaccurate, or like the person literally talked about the wrong chemical reaction, not the one that they were using. So like it was bad. That's not the one I posted. Right. What did I want to do? Oh, right. I wanted to show you what some data might look like. Here's some work in progress from Nick, who's looking at the decomposition of peroxide. And he's analyzed his data a couple of different ways, looking at mass loss, looking at also measuring temperature, see how that changes at different concentrations. He's got individual graphs, and he's got graphs that go together for all the different concentrations. It's really nice when you can put things together like this. In order to do that, he had to normalize his starting mass as 100% and then take the mass loss as percentage from there, as opposed to the different masses that he started with. So that's something that you can do to kind of make your graphs look prettier. So I wanted to show you, I kind of took one of his data points. Hi. It's the opposite, somewhere in the opposite hallway, but I don't know where. I just wanted to show you, I took a piece of his data and changed it around a little bit. Time, the total mass. He also weighed the mass of his flask so that he could see the mass of just the peroxide in the flask. And then I turned this into a change in mass. How much did the mass change every 30 seconds? So there's lots of different ways you can graph the same data. Okay, so here is the total mass, or here's the mass of the peroxide starting just for this set of data, starting around 54 grams and then going down. You can see that change, there's kind of a big change right about here, and then it tapers off. So we can actually also graph the difference. And you can see that there's a big change in the rate. The rate goes up, at the beginning, and then it comes back down. There are a lot of things you can do, and I'll post some stuff about the kinetics calculations for those of you who are doing rates of reaction. But you may have stuff like this. You may not be taking data across time, so you may only have one data point for each trial that you've done, and that's fine. Just plot it with your IV and your DV. And if you need help with graphing, setting up the spreadsheets, whatever, let me know. Happy to help. Also, I am assuming, I know there's Saturday school on Saturday, and I know the church will be here on Sunday, so I will be here, and you can come in either day. I will let you know when I know what the exact hours are, but at least both mornings I'll be available if you want to come in. Anybody have any questions right now about this that isn't just I'm overwhelmed and help? Is this helpful to kind of get that sense? Okay, great. I'm going to stop the recording.